Yes. Yep. Can you what? Well, again, here's the idea. Look, if we were all using computers, if this class was everyone has to have the TI whatever, I would teach this class, and a lot of this you wouldn't do by hand. You know? Yes. That's what this is about. Yeah. It's about the algebra of the derivative and all that stuff. That's what this is about. So, unfortunately, that's the way the class is. And if you're going to go on and do more math, at some point your calculator will not be able to do it. It's not going to be there. All right. So you've got to be good at algebra. What about this? Curve sketching. That's the next section. Ooh. So before graphing calculators, right, there had to be a way to graph functions. Computers can do them now, right? But before that, how is it done? Well, there's a set of steps, a procedure, so to speak. And here it is. It's going to be a 9-step process for us. That's what I'm going to go through. And let's just go through them first. We're going to be given a function. We're going to find its domain. We're going to find the x and y-intercepts. We're going to check for symmetry. We're going to find any asymptotes. Now here's where the calculus starts. Determine if the intervals where the function is increasing, decreasing, and constant. Find local maximum, minimum values and where they occur. Determine where we're concave up and concave down. Also determine inflection points. Make a table, sketch the curve. So basically steps 5, 6, and 7 are what we were just doing. But now we've added on all this other stuff. This is a real pain in the ass part of this class right here, okay? But if you ask a lot of Cal 1 instructors, they say, what are the main things you want a student to be able to do at the end of Cal 1? Related rate problems, the ones we were doing. Balloon is filling up at a constant, rate of blah, blah, blah. Okay, curve sketching, optimization, which is the section after this. All right, well, let's do this. I'm going to follow this procedure right here. I would like for us to take this function, f of x equals x over x squared minus 9. And I'd like to sketch it using calculus. Basically doing what we're doing in this class, all right? The first step, you should have your notes printed out for chapter 4, so I'm going off of that. First step is domain, right? What is the domain of this function? Everything except negative 3 and positive 3, right? Those are the only two. So the way we say that, negative infinity to negative 3, union, negative 3 to 3, union, 3 to infinity. That's the interval way of notating the domain. Second step, X-Intercepts. How do you find the X-Intercepts of a function? You take it and you set it to 0. But our function is a fraction, so you only have to set what to 0? The top. And if you set x equal to 0, holy crap, it's already there. X is 0. That's your X-intercept, right? How do you find Y-intercepts for a function? You plug in 0 for x, don't you? You replace x with 0, and you actually get 0 again. So the x and y-intercept are actually the same point, aren't they? It's the origin. I would ask you if you have any questions, but I know you're not going to answer me, so I'll just carry on. Check for symmetry. I'm going to skip this. I'm not going to ask you to check for symmetry, because to check for symmetry means that you have to understand what even functions and odd functions are, and we could spend a lot of time doing that, and it's something you're supposed to know, but I know a lot of students don't. It's okay. We can live without it. All right? We can live without it. It just can speed things up later, but we'll skip. Okay, find asymptotes. What type of asymptotes are there? There's two that we usually study in college algebra. Vertical and horizontal. Okay, where do vertical asymptotes occur? They're vertical dotted lines, right? But where do they occur? Algebraically, in our function, here is our function. I'll put it back up here. Don't vertical asymptotes occur whenever our denominator is 0? Right? Where our denominator is 0. So 3 and negative 3, right? So 3 and negative 3. Those were the points that weren't in our domain, right? But what we need to recognize is that at those points, we will have vertical asymptotes. How about horizontal asymptotes? Anybody remember how to find the horizontal asymptote of a function? What does it mean, horizontal asymptote? Isn't it what's happening as you go out the sides? Isn't it? Yes? We're asking ourselves, what is the function doing as you go out to the sides forever? Exactly. You're asking this question. What is the limit as x goes to infinity of the function? That's what you're asking. Tell me what's happening in the function as I let x go out forever to the right. So what is the limit as x goes to infinity of x over x squared minus 9? So let x go to infinity, everyone. What do you get? What form limit is this? What form do we have? Infinity over infinity. Good. What do you do when you see infinity over infinity? L'Hopital. Good. Take L'Hopital's rule here. What's the derivative of the top? 1. What's derivative of the bottom? 2x. Now, let x go to infinity again. What do you get? Fixed over infinity. Where does that go? 0. Right? So you have a horizontal asymptote of 0. That means as you go out to the sides, this function is headed to 0, which is the x-axis, isn't it? Isn't 0 the x-axis? I'll draw a little picture next to this. We're saying as you go out to the right, our function is headed to 0. That's like the x-axis, isn't it? Like that. Now, it might be coming up from the bottom also. It's just going to depend later when we draw it. But I can guarantee you that's what's happening. What if we went to negative infinity instead of positive infinity? Wouldn't we still get infinity over infinity? We do L'Hopital, and then you get fixed over negative infinity. That would still go to 0. So out the left side, it's also going to 0. All right, so for asymptotes, for horizontal asymptotes, you actually have to take a limit. Step 5. Determine where, I want to know where f is going up, where f is going down, where f might be constant. Here's what I use for constant, just a flat arrow like that. So when we talk about a function and where it goes up and down, what do you have to do? Take a derivative, right? So I'm going to start a new page. I'll start this over again. So I need to take a derivative. The derivative of this function is 1 times the bottom minus the derivative of the bottom times the top all over the bottom squared. Now that's very similar to the one you did in class just a second ago, isn't it? All right, let's go ahead and clean that up. What do we have here? Is that negative x squared minus 9 over x squared minus 9 squared? Do y'all agree with that? No? Can't simplify that, right? Can't cancel the x squared minus 9? Because they're both negative, unfortunately. Now we have to ask two questions, remember? Where is that 0, and where is that possibly undefined? So where is it 0? Well, when is a fraction ever equal to 0? Only when the numerator? So don't I just have to look at this? Just the numerator to 0? Go ahead and move the 9 over. What can you tell me already? Right here, what can you tell me? You can do it the other way around too. You can put x squared equals negative 9. No solution, right? No real solution. The only way that you can square a number and get a negative is if you use the imaginary unit. The numerator is what? Did I write the problem down wrong? What was the original function? Okay, the original function was f of x equals x over x squared minus 9, right? To go from here to here, I distributed the 1 through, which doesn't change anything. It's just x squared minus 9. And then I did these two together right here, which gives me negative, or that gives me 2x squared. So I have minus 2x squared. And then, why don't y'all ask when I ask you? I know, but if you see me do something and you don't get it, I want to help. Well, then tell me to slow down, because I'm happy to slow down. Okay, so we have no solution for this, right? But I still need to look at the fact that the second derivative could be undefined. Now, this is the first time we actually have an issue, don't we? We have an issue where? When the denominator could possibly be 0. And when is that denominator 0? 3 and negative 3 again. So I am going to get a number line out of this, right? The only two numbers that are going to go on my number line are 3 and negative 3. And I'm going to test some points. This is kind of interesting. Can anybody tell me what I'm going to get with those test points? Doesn't matter what test point I plug in. What can you tell me about the numerator? Negative x squared minus 9. What is that always going to be? Negative number, right? Because when you square a number, right? When I square a number right here, it's going to be positive no matter what. But then I put a negative in front of it. And then minus 9 is still negative. Now what about the denominator? Doesn't matter what happens with x squared minus 9, right? Because what are you going to do after you do the x squared minus 9? Square it. So you're going to have a negative on the top and a positive on the bottom. Always. Unless you plug in 3 or negative 3. But we're not plugging in 3 or negative 3.